This lecture is on acid-base titration, specifically on concepts and applications. What is a titration? This is a technique designed where an acid or base solution as the titrant is added to a base or acid solution of an unknown concentration as the analyte. pH meters or indicators are common in determining when the solution has reached the equivalence point, the point where the amount of acid in moles equals the amount of base in moles. There are 4 types of acid-base titrations. 1. Strong acid, strong base. 2. Weak acid, strong base. 3. Strong acid, weak base. 4. Weak acid, weak base. For this lecture, we will discuss the first 3 titrations. In a strong acid, strong base titration, when strong base is added to a strong acid, the equivalence point is pH equaling 7. In reverse, the equivalence point is also pH equaling 7. In a weak acid, strong base titration, when strong base is added to a weak acid, the equivalence point is pH greater than 7. In reverse, the equivalence point is pH less than 7. In a strong acid, weak base titration, when strong acid is added to a weak base, the equivalence point is pH less than 7. In reverse, the equivalence point is pH greater than 7. Here is a practice problem for you to try. Predict the expected pH of the following titration, specifically at the equivalence point. Is the expected pH less than, greater than, or about 7? The 3 titrations are A, HCl versus NH3, B, HCOH versus NaOH, and C, CH3COH versus NaOH. Indicators can be used to determine when the amount of acid equals the amount of base. Electronically, a pH meter can provide monitoring the progress of a chemical system. Each indicator has a color under acidic conditions, before the equivalence point, at the equivalence point, intermediate, and under basic conditions, beyond the equivalence point. Let's look at some common indicators. Before you are some common indicators from crystal violet to alizarin yellow R, and their visible colors observed at their respective pH ranges. The Henderson-Hasselbalch equation can be used for looking at a relationship between the eventual color of a solution dependent on the ratio between the concentration of the indicator in base over acid, which equals 10 to the difference between pH and pK. The color of the solution depends on the ratio of concentration between HIN and IN-. If the ratio is 1, the indicator solution will be intermediate in color. If the ratio is greater than 10, the indicator solution will be the color of IN-. If the ratio is less than 0.1, the indicator will be the color of HIN. Here are 3 indicators for display showing the colors in acid, endpoint intermediate, and base form. At the left is bromothionyl blue, whose colors from acid to base form are yellow, green, and blue. At center is phenolphthalein, whose colors from acid to base form are colorless, light pink, and dark pink. At the right is bromocresol green, whose colors from acid to base form are yellow, green, and blue. Here is the table summarizing the relationship between pH and pK, the ratio between base and acid form of the indicator, and the resulting color of the indicator. Here is a review exercise for you to work on. Look at these graphs below and answer the following questions. A. Which graph best replicates a strong acid versus strong base? B. What indicator is best for titration C? C. What is the approximate pH at the equivalence point in titration B? For the remaining part of this lecture are solutions, review exercises, or problems. Please do only after completing these exercises.